Step 1, wake up early, gonna rise with the sun. Step 2, get some food in you. Step 3, think real hard about what you wanna be. Step 4, everybody just do your thing.
Wake up, today's gonna be a good day. 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 Wake up, today's gonna be.
Welcome to Tales from the Field. My name is Bradley Ball, and it is so good to have you with us. We are off for Thanksgiving, enjoying time with our family and friends, and we hope you are enjoying time with your family and your friends. So right now, we have produced a little bit of some technical content. This is a small snippet of a presentation that I give to user groups that I've given at conferences all over the world. When I do a session I like to call Introduction to Essential SQL Server Concepts. What I'm going to cover specifically is locking and transaction isolation levels. It's really important to understand the internals of SQL Server, and this is a part of that process. I'm going to break this down to a couple different videos, so they're very easy for you to be able to consume. Quick message, if you haven't, don't forget to like and subscribe to Tales from the Field. We have a lot of great content. We also have live shows, typically every Tuesday and Thursday at 1 p.m. Eastern Time. All right, so enough about that. Let's talk about why we learn the internals. Learning the internals is really, really important. Typically, IT experts learn backwards. We go to college, we might get a degree, we get a certification, something like that, and then we get the job. And in the job, we find out a whole bunch of things that honestly were not covered in the classroom. It's learning backwards. It's a little bit like watching Godzilla backwards. If you watch Godzilla backwards, it's a heartwarming tale about how a giant monster, moonwalks through a ravaged city or multiple cities and slowly goes to sleep somewhere on the earth. Heartwarming, right? But doesn't give you the full picture. Think about this like an engine. If you had a car and your car was running poorly and you brought it to me and I'm the mechanic, we open up the hood, I need to tell you more than, the rubber thingy connects to the metal thingy, right? You wouldn't have a lot of confidence. You wouldn't want to leave your car with me. So what we do is we need to have knowledge in these concepts so we can communicate them to the people we work with. Often I like to think of these folks as our customers. And when I worked at, say, public supermarkets or at the office of the president or anything like that, my colleagues were my customers. And often I needed to be able to explain something in a technical fashion to make them feel better. That's why it's important that we learn these internals. It teaches us the vocabulary to be able to communicate that we understand what's going on with SQL Server and the engine. So first thing that we're going to talk about is we're going to talk about ACID. This is not the fun sort of ACID, but it did come out of college, so it has that going for it. The type of ACID that we're talking about is atomicity, consistency, isolation, and durability. These concepts came about in a white paper in the late 1970s, and they are the foundational thoughts that surround relational database systems. Atomicity is that each transaction is an atomic unit of work. Either all of it completes or none of it completes. Consistency says that when a transaction occurs, I must have all my data in a consistent state before I can release the transaction. Isolation is my transaction should operate in isolation in one another. If you have a stored procedure and I have a stored procedure, everything that executes within my stored procedure needs to be a transaction, or it could have multiple transactions depending on how we've defined it. But it needs to be scoped to do that work in isolation of your stored procedure. We shouldn't be accessing the same data at the same time. Think of this as a checking account. If you've got a spouse and a partner and you're going on vacation, you've got $3,500 in the checking account, and you're going to transfer that out because you're going to use that in the vacation. You don't want your partner to go in there and transfer out that $3,500 at the same time that you're transferring it out. There are safeties in there in the bank to make sure that you don't get that $600 out. The bank wouldn't like that. Similarly, there's something called durability. Durability is the complex logging mechanism that is essentially the transaction log within SQL Server. It says that any transaction, as long as it has been committed, it might not even been hearted to the data file, but as long as it has been committed, when the system goes offline, when it comes back up and online, those transactions will be present in the data. So that means if I pull out that money from my checking account and the power goes out, the bank can't go, oh, sorry about that, $3,000 gone. We just get to keep that money. No. What happens is it's an atomic unit of work, right? Either all of it commits or none of it commits. And that durability in that transaction log makes sure that if it rolled back, the money goes back in my account. But if the transaction processed and I transferred that money wherever I needed to, then it has fully processed and that transaction went through. So durability is very, very important. And as we talk about the transaction log later, it's one of those things that we'll come back to. So after we've established what asset is, we can look at our transaction isolation levels. Within SQL Server, we have 5 transaction isolation levels: serializable, read committed, read uncommitted, repeatable read, snapshot isolation. Serializable is what I like to call like the NBA power forward, doesn't play well with other people, elbows out, boxes. Serializable not only locks its data with its lock, but everything surrounding it on the page. So it's completely inaccessible to a transaction. You may say, well, Brad, why would I ever want more blocking in my transactions? Part of the reason, I was working with a hospice company once, and a hospice company provides end-of-life care to dying patients. And this hospice company had a system when the doctor was changing the morphine level for a dying patient, they would lock everything in the system so the nurse couldn't even read what the morphine level was, because if the doctor was adjusting it, they didn't want to accidentally have the nurse increase the dosage or change anything. So everything is locked in the application system. The application developers also lock that as well as they could in the stored procedure. They use serializable. I found this code. I was working with this company to help optimize stuff. I went to developers. I said, why do we do this? They told me, and I went, that's a valid business reason. That's a valid business reason for us to use this. Now, read committed is the default SQL Server isolation level. What it says is when I have a transaction that has been completed, then I can release my locks, and then other resources can read it. That's very important to keep in mind. So read uncommitted, this is something that we can actually set at a statement level, like serializable. Read committed is actually set at a database level. Read uncommitted says I can get around an exclusive lock and I can go ahead and read that data. It's very commonly also referred to no lock, but we want to encourage people to use read uncommitted transaction isolation level instead of no lock, but it allows us to be able to get around the data and make a dirty read. Very important concept. This is if the business can use it. Clearly, if I was that hospice company, I would not want read uncommitted to be utilized in the application that we were just discussing. However, if I'm working for a grocery store and we've got an analytics system, and what we're doing is we're processing data from our stores, we want to be able to report on it, we might be ingesting data, and we want to allow our business users to access that data. Well, it doesn't really matter at 1040 if it looks like the number one thing we're selling is Captain Crunch, but it turns out it was actually Strawberry Pop-Tarts. Strawberry Pop-Tarts was ranked at number 2, Captain Crunch was number 1, but when we look at things at 5 p.m., oh, it turns out it was actually Strawberry Pop-Tarts the whole time. That's not a life or death decision, right? So the business can take a dirty read. And to them, it's more important that my report's processed than I sit there and wait for a lock to finish running so I can access the data. So again, based off the business environment, it might be completely justifiable to use read uncommitted. Repeatable read. Look, if you are actively using repeatable read, I want to hear from you. I have never met anyone who has used repeatable read in a production situation. I have asked countless people as I went around the US and I talked to user groups and I talked to audiences at Microsoft offices and I talked to people at conferences. I once had an 800-person room at PASS. I asked this question. One person out of the entire audience raised their hand. They ran down in the break and they were out of breath, and I said, how are you using repeatable read? And he said, I'm the DBA. I just got the job. The code is crap and I haven't been able to rip it out yet. And I said, thank you so much for running down here. I really appreciate you. However, that's not a valid reason to use repeatable read. The only reason I've seen repeatable read used is in a demo for someone like me that's trying to show people concepts, because it holds a shared lock until the statement finishes. So if I want to show an example of holding an excessively long shared lock and blocking an exclusive lock, it's good for me to use in a demo. But originally I saw it in some code usage that we had for in-memory OLTP demos. But traditionally, I don't see anyone using this in production. If you do, please let me know. I'd love to know about it. And then the last one is snapshot isolation level. Snapshot isolation was actually introduced in SQL Server 2005. The reason that it was introduced was to allow compatibility or closer compatibility with Oracle for people who were migrating from Oracle to SQL Server. By default, readers do not block writers, writers do not block readers. And the way it does this is it enables a process such that if we have, let's say, 5 transactions coming in, 4 of those transactions are readers, one of them's an exclusive lock, it's a writer, it's going to get a hold of some data and it's going to update it. Well, these 4 readers want to come in and they want to read that data. What we're going to say is they're blocked, and instead of waiting, what we do is we create a copy of that record while that exclusive lock is maintaining access to that data. We put it over in the TempDB. Those 4 readers are now redirected to the TempDB for them to be able to read that data and return it. And it is a transactionally consistent set of data at the point in time that the query was executed. So it's a little bit different than a dirty read, because it's just the copy of the data prior to whether that transaction completed its update or it rolled back and it didn't update. But it's the last version of that. There's 2 levels to snapshot isolation. You can enable this at a statement level, or you can make it the default transaction isolation level for a SQL Server. When we do our demo, there's 2 statements that you have to look at, that you have to execute in order to get it to be the default level. Let's go to that demo right now. I've got SSMS open, and I'm going to use my demo compression partition database. You can see right there, I've got it in my use statement. Here it is in my Object Explorer. Let's go ahead, highlight that, and we'll make sure we're using the right database. And the first thing I'm going to do is I'm going to run this statement: begin transaction, update DBO, my table 1, set product name equal to Microsoft isolation level demo, where my ID equals 400. Let's go ahead and highlight that and kick that off. And now I'm going to come over here and I'm going to grab this statement. I'm going to copy this into a new window, because you see what's happened is I've got a lock on a record. We've got an exclusive lock, and if it's on record 400, if I go ahead and I scroll down here and I take a look at this, you're going to see that, let me zoom in for just a second. Remember, we're on my ID 400. That's really, really important, because if we come back over and we look, you can see I'm down at 398. Now, more than likely what's happened is we've got a lock on the page, record 399 and 400 are on the same page, and that's part of the reason we're not seeing them. So we're stopping at 398 because there's an exclusive lock on 400. We cannot access that data. So we're kind of, at this point in time, we're not able to get by it based off the way that we would typically work with locking within SQL Server. So now let's go, and we're going to run another statement to be able to dive into this just a little bit deeper. I'm going to open up a new window. I'm going to paste this in. This is one of my favorite statements. I'm going to get the session ID and some additional information. And specifically, I'm getting this from sysdm exec request. Sysdm exec request, one of my favorite DMVs. It tells me everything that's currently executing on a SQL Server instance. And we're going to join it with sysdm exec sessions. And sysdm exec sessions has this wonderful field right here, is user process equals 1. So we're going to highlight this, we're going to run it, and it's going to return us everything. It's going to filter out all the background noise, and we get 2 results back, session 57, 58. Well, I can see based off my browsing window, I've got 57 and I've got 58, but where's 54, where our transaction is firing off from? I don't see that at all. So let's go ahead. Now we're going to execute, we're going to run a query specifically against sys sessions 454, and I can see it's sleeping. Well, of course it's sleeping, right? That's its natural result. It's completely understandable that it would be sleeping, because you see what we did is we said begin transaction, update a table, and now it's waiting. Do we commit it? Do we roll it back? And a transaction is an atomic unit of work. And right now, our atomic unit of work is not complete. So of course, it's fallen asleep. While it's fallen asleep, we've still got our exclusive lock. Now I'm going to show you that we can actually get past this by using our transaction isolation level. Set transaction isolation level, read uncommitted. This is again similar to no lock, but we want to use this instead. And not only am I going to read the record, I'm going to read record 400 that our lock is on. So I'm going to go ahead and I'm going to run this, and you can see I immediately got it. You look at that, you can see the product name is Microsoft Isolation Level Demo. That's very important for us to note. Again, what this is a dirty read. A transaction is in progress, and we're getting past the exclusive lock to be able to read this. As we stated before, grocery store, right? If we've got a business use, a reporting case for this, dirty read might be perfectly acceptable. But that's also something that we need to keep in mind, because again, we need to understand the business use case for this. If I came back over, I look at my statement, we've been running for about 3 minutes and 1 second right now. Still completely blocked. Our session is still asleep. One of the things I want to make sure I note, we talked about snapshot isolation. If I wanted to turn on snapshot isolation, I would run this first statement. I would run this second statement to make it the default for my database level. So now let's go ahead and let's move back up. I'm going to roll back this transaction. Did I say roll back? Yes, I did. So as a matter of fact, you can see instantaneously our query finished. 3 minutes and 27 seconds worth of processing, 18,000 rows returned. Let's scroll down and we're going to look specifically at row 400. And what do we have here? Not some Microsoft demo. We have some product, because we rolled back the transaction. And if we go back and we look at the value, Microsoft Isolation Level Demo, you can see that again, that this was a dirty read. So again, we need to make sure that the business case is right for this, but it's completely possible for us to use our transaction isolation levels in such a way that it will benefit us for our business use case. So with that demo complete, let's review what we talked about. We talked about our ACID properties of a transaction. Specifically, the locking example that we show had to do with Atomicity. And then we also discussed the default transaction isolation level of SQL Server being read committed, and how we were able to get by it with read uncommitted transaction isolation level, essentially allowing us to have a dirty read. Keep in mind, we also talked about the need for the business context, how the business context will drive really what our locking strategy is going to be that we can end up using, whether we can accept dirty reads in a reporting scenario, whether we have to have read committed transaction isolation level, or if we even want to have something a little bit stricter than that. Those things are very important, and it is important for us to understand how the technology relates to the business and what the business needs are. Thank you so much for joining us. Again, we hope you have a wonderful Thanksgiving, and we will see you next week on our live show. Thank you for joining us for Tales from the Field. Bye, everybody.
Do this every day, call it replication. Wake up, today's gonna be a good day. 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 Wake up, today's gonna be a good day.